In lesson 3, we're going to look at another way to solve quadratic equations, and the method that we're going to use in this lesson is called the quadratic formula. And the nice thing about the quadratic formula is it always works. So the quadratic formula, when in doubt, and if you can't figure out how to factor, you don't know how to complete the square because the leading coefficient's too difficult, you can always use a quadratic formula. So the quadratic formula always works. So that's the nice thing about the quadratic formula. So you probably remember it. It's whenever you have a quadratic equation in the form ax squared plus bx plus c, and it has to be set equal to 0. So basically your equation must be in standard form, so in this format here. And then you have your two solutions. So you're probably used to seeing the quadratic formula like this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which really means these two solutions above it. You have a positive case where you add the two terms, and then you have a minus where you subtract the two terms. So let's go ahead and look at some examples for how to solve this. So first thing you always have to do is get your equation in standard form and set equal to 0. So in order to use the quadratic formula, you have to get your equation in standard form. So standard form, which means your exponents are in decreasing order, and set equal to 0. So that's your first step. So looking at this equation, I need to get this so it's set equal to 0 and also in decreasing order for the exponents. So I'm going to keep the 2x squared where it is, and then I'm going to bring the 4x over, so it's going to be plus 4x. And then I'll bring the 3 over, so it'll be minus 3 from both sides, and then I'll be left with 0. So I basically just moved this stuff over. So then what you need to do is you need to identify what a, b, and c are. According to my standard form up here, ax squared plus bx plus c. So the a is always a number in front of x squared, b is a number in front of x, and then c is the number at the end. So we have a equals 2, b equals positive 4, and c equals negative 3. You always keep the signs in front of these numbers too, so just keep that in mind. So then we're going to go ahead and we're going to plug in. So I have negative b, which is going to be negative 4. When I plug in, I always plug in using parentheses because you want to make sure that you remember to take care of any negatives. So notice that it was negative and then I plugged in parentheses for b, 4, plus or minus, again, parentheses for my b, minus 4ac all over 2a. And then you're going to simplify this in a couple pieces. So the first thing you want to do is you want to simplify underneath the radical. So we have x equals negative 4. And then underneath the radical I have 16. And then I have negative 4 times 2 gives me negative 8 times negative 3 is going to give me positive 24. And then I have 4 at the bottom. And again, I'm going to simplify underneath the radical. So I'm going to add the 16 and 24, so we get 40 all over 4. So this is one of the answers, so you could put that in a calculator and you could get decimal approximations, but typically when you have these, you want to simplify your answers. So if you remember back from our last unit when we had radicals, if I have the square root of 40, I'm looking for the biggest perfect square and then the non-perfect square. So 4 and 10, because 4 is the biggest perfect square that I can multiply by 10 to get 40. So then you just reduce that. And then what I'm going to do is I'm going to go ahead and I'm going to replace the square root of 40 with the 2 radical 10. So I'm going to continue simplifying. And again, I'm replacing. And then keep everything else. And then when you go to simplify, because you have a plus or minus between the two terms here, what you want to do is if you can simplify, you have to be able to simplify both pieces. So meaning I have to be able to simplify the number in front of the plus or minus and the number after the plus or minus. And remember that that 2 belongs with the radical 10, so as long as I can simplify the 2 with the 4, then I can do it. So if you look, when I take 4 and I divide it by 4, So we're going to have x equals negative 4 divided by 4. It's going to be negative 1. Plus or minus 2 divided by 4 is going to be 1/2. Radical 10. So that's it. So that would be how to simplify. So let's look at another example. So here is a good case where you would definitely want to use a quadratic formula just because you have fractions involved. Um, Although we can eliminate the fractions. So remember, quadratic formula is whenever you don't know a method of how to solve, so you can't factor it, you can't do completing the square because numbers become too difficult, you can always do quadratic formula. So quadratic formula always works. So if I look, I'm going to first get this in standard form. So I'm going to bring the 1/2 over, so it's going to be plus 1/2 equals 0. And keep in mind, you could do the quadratic formula right from here, but then you're going to have all of these fractions. So as a good review, we want to remember how to eliminate fractions. So whenever you have a fractional equation, it's much easier if you kind of just eliminate them so that you don't have to worry about them. And you can do that by multiplying by the LCD. So I'm going to multiply this entire thing by the LCD, which the LCD, the least common denominator between all three terms, is going to be 10. So basically what I do is I multiply every single piece by 10, and it'll just make my math much easier. And you're allowed to do that because you're doing it to every single piece. Whatever you do to one side, as long as you do it to the other, it's fine. So 10 times 1/10, it's just going to cancel out and be 1. So I have x squared. 1 times x squared, so it gives me x squared. 10 over 5 is going to give me 2 times 1x, which is just going to be minus 2x. Here I'm going to have 5, so plus 5 equals 0. So now if I do the quadratic equation, my numbers are much easier, even though in the previous one you still could have used the quadratic formula. So in the end, you would get the same answer. It's just by multiplying by 10 first, it makes your math much easier. So I'm going to go ahead, I'm going to identify A is going to be 1, the number in front of x squared. B is going to be negative 2, and C is going to be 5. And we're going to go ahead and we're going to plug into the quadratic formula. So x equals negative b plus or minus b squared minus 4ac all over 2a. So when we plug in, again, keep your parentheses. So I'm plugging in b. Notice b this time is a negative number. So it's a negative times b. So a negative times negative 2 plus or minus the square root. Again, keeping in mind that you have parentheses around any number you're substituting in. So I plug in a and c all over 2a. And then I'm going to go ahead and simplify. Negative times negative. So a negative times negative 2 is actually going to be positive 2. Plus or minus. Notice that I have a negative 2 squared, so that's going to become a positive 4 because it's negative 2 times negative 2. And then it's going to be minus 20 all over 2. And then we're going to continue simplifying here. So we have 2 plus or minus negative 16 under the square root. And hopefully you're remembering that whenever we have a negative 16 underneath the square root, because this is a negative, it's going to become an imaginary number. So I'm going to have x equals 2 plus or minus. So remember, because it's a negative 16, you got to take out an I. When you take the square root of 16, it's just going to be 4. So it'll be 4 times I over 2. And again, you can simplify as long as you can simplify both pieces. So I have 2 divided by 2 is 1, plus or minus 4 over 2, which is 2, and then you just keep the I. So there are your two solutions. So keep in mind this would be 1 plus 2i and 1 minus 2i are your two solutions. All right, let's look at another one that looks a little bit different to start. So for this one, what we need to do is, because it's not in standard form to begin with, we need to first multiply this stuff out. and bring over that 4, and then we can get this in standard form. So if you look, I remember we have to have it set equal to 0. So you can bring over that 4 first, and that again will remind you that you actually do need to multiply this stuff out before you can do any kind of factoring, completing the square, or quadratic formula. But in this case, I'm going to do quadratic formula. So to multiply this stuff, remember that's where we set up the box. So we have 2x minus 3 and then 2x minus 1. Multiply, so we have 4x squared, negative 2x, negative 6x, and then I multiply, I get 3. Combine your like terms, so we have 4x squared minus 8x plus 3. And then go ahead and you can replace it over here. So 4x squared minus 8x plus 3 plus 4 equals 0. And remember, I brought that 4 over. I added the 4 to both sides. So now we just have to combine any like terms. So we combine the 3 and 4, we get 7. And then from here, we can go ahead and we can figure out our a, b, and c. So we can use the quadratic formula. So again, this would be a good case for quadratic formula. Even if it didn't tell you to use quadratic formula, I would still, just because you have a leading coefficient that's not equal to 1, so you would have to factor by grouping, or try to factor by grouping and find out maybe it doesn't even factor. So I would say factoring is kind of more work in the end. And then completing the square isn't going to work because you have a 4 out in front, and if you divide everything by 4, it's going to give you 7 over 4 for this constant term, which is just going to become some messy numbers. So this is a really good problem where you definitely would want to use quadratic formula just by looking at it. So I'm going to go ahead, I'm going to plug in. So we have x equals negative b plus or minus b squared minus 4ac all over 2a. So go ahead and plug in. So we have x equals negative. Remember, we're plugging in with parentheses, so I have negative 8 going in for b, and I still have that negative out in front. Then I have b squared, again, negative 8 squared minus 4a, which is 4, and c, which is 7. All over 2a, which is 2 times 4. So negative times negative 8 is going to be positive 8, plus or minus. We have 64. Remember, it should be a positive number if you're squaring a negative. It should always be positive. And then we have 4 times 4 times 7, so it's going to be minus 112 all over 8. And then we have 8 plus or minus. We simplify the numbers under the square root, so we get negative 48. So again, you should be thinking, okay, it's going to be an imaginary solution. Keep the 8 on the bottom. And then we're going to go ahead and we're just going to simplify that radical 48. I'm going to just simplify that off to the side and then plug it back in. So radical 40, negative 48. Again, you're going to pull out an I, and you're going to have your perfect square, your non-perfect square. So the perfect square is going to be 16, and 16 times 3 is going to get you 48. So square root of 16 is 4, so I'm just going to put it as 4i, because typically you put the number in front and then keep the square root of 3. So then I'm going to take and I'm going to plug that back in. So it's 8 plus or minus 4i radical 3 all over 8. And again, you can simplify as long as you can simplify these terms here. So I can go ahead, 8 divided by 8 is 1, plus or minus 4 over 8 is going to be 1/2. And you can keep the I, radical 3. So let's look at one last example, which is going to be an application problem or a word problem. So in this example, it says if an object is thrown downward with an initial velocity of 20 feet per second, the distance, s of t, in feet it travels in t seconds is given by this function. So here's my function. What we want to do is we want to find how long, so basically what it means is we're going to be finding t, does it take the object to fall 400 or 40 feet. So 40 feet is going to be the distance. So that's going to be the s of t. So we want to find t when s of t equals 40. So essentially what you're going to do is you're just going to take and you're going to plug in 40 feet into this equation. Keep in mind that we're going to often see quadratic equations modeling how an object is thrown, and we'll talk about that in the next unit more about the graphs of quadratic functions, but just kind of keep that in mind right now. So we're going to go ahead and we're going to take and we're going to plug in. So I'm going to plug in 40 for s of t, and then I'm going to just use this equation. So 40 equals 20t plus 16t squared, and then we need to solve it for t. So it says find t, which means use quadratic formula is going to probably be your best bet since you have some big numbers involved and you have a leading coefficient not equal to 1. So what I need to do is I need to get this in standard form. So the first thing I'm going to do is I'm going to write it as 16t squared plus the 20t, just because we need it in standard form, which means decreasing order. And I also need to bring over that 40. So I'm going to subtract over the 40, so it equals 0. So I basically rearranged these terms, subtracted 40, and set it equal to 0. And now what you can do is you could use the quadratic formula as is, but again, to try to make your math easier, if there's a common factor between these, go ahead and factor it out. So right away, I'm noticing that 4 is going into all three of these numbers. So I can divide everything by 4, and it'll just make the numbers easier to work with. So you're going to have 4t plus 5t minus 10 equals 0. And keep in mind, if you didn't see that you could divide everything by 4, you can totally use this equation here. It's just you're going to be dealing with bigger numbers in the quadratic formula. So then from here, again, this is another example where you'd want to use quadratic formula because trying to factor by grouping might not even work. So you could end up doing the whole thing and finding out it doesn't work. Completing the square isn't going to work very well because you have a 4 as leading coefficient, and when you divide everything by 4, it's going to be fractions. So again, quadratic formula is really your best bet here. So figure out a, b, and c. So a is a number in front of t squared, b is 5, and c is negative 10. And then we're going to go ahead and we're going to plug in, so negative b plus or minus b squared minus 4ac all over 2a. So we have x equals negative b plus or minus, we have b, which is 5, minus 4ac all over 2a. And then we're just going to simplify. So negative 5, or negative times 5 is negative 5. And then we have plus or minus square root of 5 squared is going to be 25, minus 4 times 4 times 10. So 4 times 4 is going to give me 16, times negative 10 will be 160, but we have a negative times a negative, so it becomes positive. So it's going to be plus 160 all over 8. So we have negative 5 plus or minus 25 plus 160 is going to give me 185, and it's going to be all over 8. So then we're going to have two solutions here. So we have, since this is an application problem, you really want to look at your solutions. So the first one, we're going to have negative 5 plus the square root of 185 all over 8. And that, when you put it in your calculator, is going to get you approximately 1.075183814, but I'm just going to leave it as 0.1075. And then we're going to go ahead and we're going to put the other one in our calculator. So negative 5 minus the square root of 185 all over 8. And let's get a decimal approximation for that. And then for that one, we have negative 2.325. So if you think about back to the problem, it says how long does it take the object to fall 40 feet? So we would just keep this solution here, and we would reject this one because it's negative. You can't have a negative time. It can't take negative 2.325 seconds to fall. So the answer is going to be The time equals 1.075 seconds. And just another thing too, I just realized here that because my equation had t in it, when I'm solving, these should have all been t equals. If you put x equals, it's not a huge deal, but whatever variable you're solving for, that's really what should go there. So since I was solving for time, it should be t equals in my quadratic formula because the variable is time in my equation. So that's it for using the quadratic formula. So remember, quadratic formula always works. Sometimes, it seems like a longer process because of the formula, but it will always work.